Law of signs is a rule that helps us find both the missing sides and the missing angles of a triangle. Now, we've heard this before, and we talked about Pythagorean's theorem, but Pythagorean's theorem helps us find really the sides of a right triangle. Remember, it has to have a 90 degrees. Law of signs is a lot more complicated, but that's only because it can be used on 90s, but it's made for non-right triangles, okay? Because we can't use Pythagorean's theorem on non-right triangles. So these triangles we see are not going to have 90-degree angles on them. So for example, let's say we had something that looks like this. Obviously not a right triangle, okay? So let's go ahead and label. Now let's say this was angle A, this was angle B, and this is angle C. Now, one thing I want you to make note of is from now on, I'm going to be using capital letters to represent angles. So big angle A, big angle B, and big angle C. And those angles open up and create sides. So angle A right here opens up and creates this side over here, which is little a. So the big angle A, little side A are across from each other. Same thing down here. Angle B opens up and makes side little b, and big C opens up and makes side little c. Okay, so little letters are sides, big letters are angles. Now, what the law of signs actually says is this. We can make ratios of them. If I set little a over the sine of big A, that will be the same as little b over the sine of big B, which will be the same as little c over the sine of big C. All right, so that is law of signs. Now you'll see in here there are three sets of fractions, two equal signs. We don't usually have something that has two equal signs. So one thing to make a note of here is we're really only going to use two sets. We use two sets of letters in each problem. Okay, so we may use A and B, B and C, or A and C, but not all three at once. All right, so let's see what we're talking about here. They're going to give us a random triangle here. Obviously not a 90. Okay, there will be no right angle on this. Let's label some stuff. Let's go angle A, angle B, and angle big C. So big letters. They'll give us some numbers here. This corner is 54 degrees, and this corner up here is 83 degrees. They also give us that there's a side length of 11. All right, now the instructions will say find side AB. So the side from A to B. So let's go ahead and identify which one that is. From A to B, that one is this one down here. Now they're calling it AB. We know that better as, okay, let's look what's across from it. Big B, little b. We're trying to find little b. Okay, so here's how we set it up. Law of signs is really about pairs. Remember, we need two pairs, either A and B, B and C, C and A. We need pairs. Now, obviously, we're trying to find B. I have little b, I have big B. This is a great start. That is one of my pairs. So I have B's. Do I have another pair of letters? Let's see. Do I have angle C? No. Do I have little c? No. Okay, so that doesn't help us. Do I have another set? I have big A, and I look across from it. This 11 is little a, so I can go ahead and label that. So I have B and A. So I'm going to go back up here and use the B and A part. These ones. So I'll go ahead and write that out. A little a over sine big A is equal to little b over sine big B. Because if I look, I have at least three of those things. Do I have little a? Yes, 11. Do I have big A? Yes, 54. Little b, that's what I'm trying to find, and I'm okay with that, so that's going to stay there. And do I have big B? Yes, I do. So I have three of the four things. That means I can solve for B. So let's plug in everything we have. Little a, again, is 11. The sine of big A, 54 degrees, equals little b is what I'm trying to find, and big B is 83 degrees. And from here on out, it's a lot of calculator work. So I want to do this side first. Let's find out what 11 divided by sine 54. So I go on my calculator, 11 divided by the sine of 54. Okay. I get that to be a 13.5967 equals b over sine of 83 degrees. All right, so again, I want to get b by itself. I need to move the sine 83. Now I could make this into a decimal right now, or I could just know that I need to multiply both sides by sine of 83. Leaves me with just more work to do on the calculator. So what I do to one side, I do to the other. Multiply this side by sine of 83. So those cancel, and now when we multiply this side together, I've got the sine of 83 degrees times 13.5967. That comes out to be equals 13.4954-ish. Okay, so I'll go ahead and highlight that answer right there, and I just want to check, kind of make sure things make sense. I got an answer of this side being 13 and about 13 and a half. I see another side comes out to 11, so this is in the right neighborhood. If we get something ridiculous like 200 or something less than 1, some decimal, then things are a little off. So you want to kind of check, make sure everything still makes sense. All right, let's go ahead and try another one. So, for example, they give us another triangle here. Go ahead and label the corners. We've got corner A, B, and C. They tell us that angle A is 65 degrees. They tell us angle B is 91 degrees, almost a right triangle. And then they give us some side lengths. They tell us that this side is 13, and they'll tell us find side AC. Now we'll go ahead and highlight AC. AC is this one down here. We don't really want to call it AC, we want it as a single letter. So if I look at what's across from it, that's big B, so this side is little b. Obviously, B is what I'm trying to find. I do have big B, so there's one pair. The other pair, I notice I don't have any C's, no big C, no little c, but I do have big A, little a. So I have a pair of A's, I have a pair of B's. So that's the setup we want to use. A over sine big A equals little b over sine big B. So same setup as last time. And let's plug in everything we have. So little a is 13 over the sine of big A, that's 65 degrees, equals little b, we don't know, that's what we're trying to find. And then sine big B, that's 91 degrees. And again, this part over here, we'll go ahead and put in the calculator. 13 divided by the sine of 65 degrees, that comes out to 14.3439 equals b over sine of 91 degrees. Again, I can make this sine 91 degrees into a decimal right now, or we can leave that all for the calculator. If I multiply this side by sine 91, see one on bottom, one on top cancel, I can multiply it to the other side. So on the calculator, sine of 91 degrees times our previous answer. Alright, so times the 14.3439 comes out to B being equal to 14.3417. Alright, so let's go ahead and check that number, make sure it makes sense on our picture. Should be that one right there, 14-ish, I got a side of 13. I've got something that's a 14. This looks like it's in the correct neighborhood. All right, let's keep trying some of these. So these two problems we've just done, those helped us find sides. Now we can also find angles. All right, so again, a triangle, they give us, this is B, this is big C, this is big A. And they give us some sides, 25 and 14. This angle up here is 89 degrees. They're going to tell us find angle B. All right, so let's label what we have. So obviously this is big C, this 14, it's across from big B, so this is little b. Down here, 25, it's across from big C, so this is little c. We want pairs. They're telling us we want to find angle B, so this is part of the equation. If we have big B, we also want little b, and we have both of those. So there's one pair. The other pair is going to be big C and little c. So in this case, we're using B's and C's, no A's. So let's set up the equation with B's and C's. So if I go back up here, I'm really just using this part of it, the B and the C part. So let's go ahead and put little b over sine big B equals little c over sine big C, and plug in everything that we have. We should have 3 of the 4 things. So little b is 14. Sine big B, I don't know, so I'm going to leave it as big B, equals little c, 25, sine of big C, 89 degrees. All right, so just like before, we've got one side that's all numbers, so I'm going to put that whole thing onto the calculator. So 25 divided by the sine of 89 degrees, that comes out to 25.0038. This side is still a 14, sine big B. All right, now I want to get big B by itself. All right, so over here is a 1, so I can multiply this side by sine big B. That cancels it, but I multiply it and move it to the other side, and now it's no longer fractions. So I've got 14 equals 25.0038 times the sine of big B. Because the great thing now is we're making a little bit of a mess of it, but now I can divide this side by that 25 number. What I do to one side, I do the other. And 14 divided by that number comes out to 0.5599 equals sine big B. Okay. Now I'm getting a lot closer. I need to get this B by itself. And I'm going to flip the sides of this because I like it better when it looks like this. I need to get B by itself. And if you think back, in order to get B by itself and move that sine would move to the other side, but it becomes the inverse, the opposite. So on the calculator, we got to make sure we use our inverse buttons and not the regular sine button. So I need to hit second or shift or whatever gets it to sine inverse, and then put in 0.5599. And this comes out to big B equaling 34.0489. Okay, I'll go ahead and circle that answer. Now I won't stop right there, kind of check, again, make sure everything works out. This is big B, but we got to remember big B is an angle. So this right here, 34 point something, is an angle. It has to be in degrees, 34 degrees. If you get something that's way too big, like bigger than 180, because the whole triangle adds up to 180, something's off. Okay, so this is in a good neighborhood. This one's 34. We've got an angle of 89. This all looks like it could be a good triangle. All right, let's go ahead and try one last one, finding angles. So for example, give us a triangle that looks like this. Angle A, angle B, angle C. They tell us that angle A is 25 degrees. This is a 9, this is a 12, and they'll say find angle C. Alright, so angle C is what I want to find. So let's mark that. Angle C is this one right here. Do I have little c? Yes, across from it is 9. So that's one pair. Let's find the other pair. The other pair looks like the A's. Big A, little a. So I have two pairs, A's and C's, so I can write that out. I'm going to use the A over sine big A equals little c over sine big C. And now when I fill these in, we should see that we have three numbers and one letter. Little a is this 12 number over the sine of big A, 25 degrees, equals little c, that would be the 9, over sine big C. Remember, big C is what I'm trying to find. Now this one I'm going to do a little bit differently. Maybe you're good with your cross multiplying when two fractions are equal to each other. So I can take the top of one times the bottom of the other. So we can solve it like this time. So 12 times sine big C equals 9 times that, so 9 times sine of 25, 3.8036. And maybe this time it's a little bit less work, as long as you remember how to cross multiply. Divide by 12 on both sides. We get the sine of big C is equal to, where is it, 0.316. Oh, I guess that rounds up to a 7.0. Okay. And now, remember, to get this C all by itself, I need to move the sine to the other side, but it inverses it now. So the sine inverse of 0.3170 comes out to 18.4816. And remember, this is an angle, so it has to be in degrees. If you don't put degrees, your answer is technically wrong. Alright, and we check it. That looks like it's okay. Angle C being 18 degrees. Yeah, that looks good. Alright, so the thing to remember here, we've got all these formulas. You're only going to use two at a time, either A and B, B and C, or A and C. Don't use all three. Alright, and don't forget, when you're using your calculator to find inverse, you have to use the opposite button when you're trying to find that angle, sine inverse. Remember how to shift up to that.